Welcome students. Today we are discussing the industrial production of iron. Industrial production of iron. How we can produce iron industrially. That is the topic. So the industrial production of iron and industrial production of aluminum. These are the two main points we want to study here in this chapter. So first section, it is the industrial production of iron. So there's a need large explanation needed for this preparation. So we later on hearing these sections, very important. The equations are also important. Okay, the industrial production of iron. Iron makes number of minerals. Iron make a number of minerals. The minerals like magnetite, hematite, iron pyrite, etc. Especially the iron pyrite that have yellow brazen color like gold. So the iron pyrite is known as what? Fool's gold. Viddigalude sornam. Okay, fool's gold is iron pyrite. That is resembles like what? Gold. But it is not exactly gold. It is iron pyrites. That is its name. Okay, so the main ore of iron is hematite. Main ore of iron is hematite. The hematite is molecular formula Fe2O3. The impurities that are present in hematite that have low density. The impurity that are present in hematite have low density. So that we can concentrate the ore. The first step is the concentration. We can concentrate the ore by the method of levitation or hydraulic washing. So if you take the ore, the mined ore is taken and that will be concentrated by the method levitation, or it is known as hydraulic washing. So the impurities are washed off from the ore. After that we are carrying out the stage, second one, it is roasting. If you are heat that ore in the presence of air. In the presence of air means that air contain oxygen. So we are heating the ore by passing air into the ore. As a part of that, the water will be lost and it's in the form of water vapor, because we are washed the ore that contain water, or wet ore is that. We can remove the water content by the heating process. By that water will be lost as in the form of water vapor. Then that ore contain other impurities like sulfur, phosphorus and arsenic. Isn't sulfur, phosphorus and arsenic are the other impurities contained in the hematite. After levitation, some of the impurities are lost. Then after roasting, the water is lost as in the form of water vapor. Then that ore contains sulfur, phosphorus and arsenic as the impurities. These impurities are lost in the form of their oxides. Oxides are made as in the form of sulfur. Sulfur, by passing oxygen and heating, sulfur is formed as what? Sulfur dioxide. Sulfur dioxide is a gas that will be left from the ore, and phosphorus forms phosphorus pentoxide, that also gas, it will be lost from the ore. As like arsenic oxide will be formed and it lost from the ore. By heating, passing oxygen to that, carrying out the roasting, we can remove the impurities like water, sulfur, phosphorus and arsenic from the ore. Water lost as in the form of water vapor. Sulfur, phosphorus, arsenic are lost in the form of their corresponding oxides. Okay. Then we get the oxidized or roasted ore. We get the roasted ore. The roasted hematite will be get. Then we can the last stage or the second stage that involves the extraction of the metal. We want to extract the metal iron from hematite. That need reduction. The reduction will be carried out in an equipment that is very important from this area. This is very, very important. Please listen. That instrument is known as blast furnace. Blast furnace. So blast furnace is the instrument. Blast furnace is the instrument that is used to reduce the hematite. We want to add the hematite into the blast furnace. Before that, we want to familiar with the blast furnace. This is a large or huge steel tank. The steel tank, the inner portion covered with a reflective material like brick or anything that will be highly reflective. The heat does not get to the steel tank. The inner portion is covered. Then 1000 and above degrees Celsius hot air will be passed from the lower portion of the blast furnace. 1000 degree Celsius above hot air passed from the lower portion of the blast furnace because it is very hot steel tank. That's why it is known as blast furnace. From the top of the blast furnace we are adding hematite, limestone and coke. Hematite, limestone and coke. Limestone, that's hematite Fe2O3. Limestone, that is calcium carbonate CaCO3. Then coke is exactly the form of carbon. So which are the substance added into the blast furnace from the top? They are hematite H, that resembles hematite, L limestone and C coke, it is carbon HLC. Simply you just remember HLC, hematite, limestone and coke are added into the blast furnace. These are added into the blast furnace. Then for the exam they will ask what is the role of carbon and what is the role of calcium carbonate that are added along with the hematite into the blast furnace. What are the role of these substances? We are added hematite, carbon, or that is coke and limestone into the blast furnace. First of all, the carbon is combined with the oxygen and it forms carbon dioxide and liberate heat. That will be happen at the lower portion of the blast furnace. The carbon, that is coke, combined with oxygen forms carbon dioxide and liberate heat. So exothermic reaction. By the exothermic reaction, already this blast furnace is a hot one because 1000 degrees Celsius hot air is passed. Thus again that liberate heat, again the temperature at the lower portion of the blast furnace increases due to the formation of carbon dioxide that liberates heat. So it is important, we are added coke, that carbon reacted with oxygen, it forms carbon dioxide. That carbon dioxide formed is an exothermic reaction, so heat is liberated. That is from our lower portion of the blast furnace, so the temperature at the lower portion of the blast furnace is increases. Then the formed carbon dioxide again that contain we are adding the coke, that contain the coke, it will be combined with the carbon and absorb heat and forms carbon monoxide. It is from the middle portion of the blast furnace, so it's an endothermic reaction, upper portion of the blast furnace. Endothermic reaction takes place, the temperature is low than that of lower portion. Okay, lower portion the temperature is high, but the upper portion the temperature is comparatively less than that of the lower portion because there endothermic reaction takes place and forms the carbon monoxide. This is important. This carbon monoxide is the reducing agent in this process. This carbon monoxide is the reducing agent in this process. Carbon monoxide is the reducing agent. Okay, so why we are added coke into the blast furnace? We are added the coke into the furnace to get the reducing agent. Which is the reducing agent? Is it carbon? No, carbon monoxide is the reducing agent. Carbon monoxide. To get the carbon monoxide, we are added coke or carbon into the blast furnace. Then the hematite contain a gang after roasting, and we have discussed the concentration, leviation. The impurity is not lost from the ore, it is silica or silicon dioxide. So this is the main gang that is present in hematite. This is the main gang, that is major gang present in the hematite. This is silicon dioxide, or otherwise it is known as silica. Silicon dioxide or silica. This is the major gang in hematite. Then we are added the calcium carbonate or limestone into the blast furnace. The blast furnace that are very heat or hot temperature is there, so it absorbs the heat. The calcium carbonate takes the heat and decomposed into calcium oxide and carbon dioxide. So the calcium carbonate absorbs the heat and it forms calcium oxide and the carbon dioxide. So this calcium oxide will be reacted with the silica or impurity in the ore. Silica, calcium oxide reacted with the silica and it forms calcium silicate, CaSiO3, calcium silicate. Calcium oxide combined with the silica, it forms calcium silicate. So here calcium oxide have alkaline nature, silicon dioxide have acidic nature. So silicon dioxide is the gangue impurity. The substance that are used to remove the gangue or remove the impurity, that substance are known as flex. The substance are known as what? The substance are known as flex. So the substances used to remove the gangue, they are known as flex. So here the flex is calcium oxide. If the gangue have acidic nature, we want to use basic flex and vice versa. If the gangue have acidic nature, we want to use the basic flex and vice versa. Then we get the calcium silicate as the compound. So this compound is exact, its name is calcium silicate. If the gangue and flex combine together and form, the substance is known as slag. So here the slag is calcium silicate. So gangues are the impurities. The substances used to remove the impurity, they are known as flex. If the flex and gangue combine together and form slag. So here the flex, calcium oxide, gangue, silicon dioxide, slag, calcium silicate. For the exam they will ask what is the name of the slag, what is the name of the flex, what is the name of the gangue, like that. So the name of the flex, it is calcium oxide, name of gangue, silicon dioxide or silica, the name of slag, calcium silicate. So the impurities are removed from the ore because the slag have low melting point and low density, and we can easily remove that impurity from the blast furnace. At last the hematite will be reduced. So this is the important step. Hematite. The hematite is Fe2O3 that is reacted with the carbon monoxide because carbon monoxide is the reducing agent that removes the oxygen. So that is a reduction and it forms Fe plus 3CO2. So we get the iron. That iron obtained from blast furnace, that have also includes the impurities. Again, the iron obtained from the blast furnace, after the reduction we get the iron, that involves the impurity, right? So this iron obtained from blast furnace are known as pig iron. The iron obtained from blast furnace are known as pig iron. It is not pure, that contain carbon and manganese, like impurities are there in the iron. So pig iron, this iron is known as pig iron. After refining we get the iron. Okay, after refining we get the pure iron. Okay, then we have to study about the alloys of iron. Alloys of iron. Alloys of iron means one metal combining with other metal or non-metal. One metal combining with other metals or non-metals are generally known as alloys. So here we are studying the alloys of iron. So the alloys of iron are known as alloy steel. Alloys of iron are known as alloy steel. Okay, alloy steel. So we are going to study about the alloys of iron. The alloys of iron are known as alloy steel. Alloy steel. So alloy steel, we are studying the alloys of iron. They are known as what? Alloy steel. So here we want to study three alloys of iron. These three alloys of iron, they are alnico, nichrome and stainless steel. Stainless steel. Okay, alnico, nichrome, stainless steel. So these are the three alloys of iron. The components present in alnico. Alnico, that involves, especially mainly their iron is there. Iron, aluminium, nickel, cobalt. Cobalt. Alnico, aluminium, nickel, cobalt and iron. These are the components. In nichrome, let's say you studied in physics, iron, nickel, carbon and chromium. Iron, nickel, carbon and chromium. Then stainless steel, iron, nickel, carbon and chromium. Look at that. In the case of nichrome and stainless steel, that involves same components, but their properties are different. Alnico is used as magnet, permanent magnets, used to make permanent magnets. Nichrome, heating coil. Then stainless steel, that you know, utensils. Okay, so Alnico, that include iron, aluminum, nickel and cobalt, that is used to make permanent magnets. Nichrome, iron, nickel, carbon, chromium, it is used to make heating coil. Then stainless steel, iron, nickel, carbon, chromium, that is used to make utensils. So these are same components, but they are different. So we want to understand that the property of the alloys we can change by changing the amount of components. By changing the percentage of component, we can change their nature. So how can you make the alloys? By changing the components or by changing the amount of components. By changing the components, we can change their nature, and by changing their amount or percentage, we can change their nature. So these are the alloys of what? Alloys of iron. Students, go through the equations and read the portion very well and study the sections. These all portions are very important in the industrial production of iron. Thank you.